Hello everyone, welcome to this video. In this video we're going to be talking about inverse TCP flag scanning and performing scans like your Xmas scans, your fin scans and your null scans. And the reason I'm including them all in one video is because they all deal with the same with the same overall concept, which is again using inverse TCP flags. Now the reason this is called is named inverse TCP flag scan is because you're not utilizing your typical TCP flags that have to do with the three-way handshake. Instead you're using the other TCP header flags that we had actually discussed in the networking fundamentals section or module, and those are your fin, urge and push flags, right? Given that we are not following the methodology of the TCP three-way handshake, you might be asking yourself, well, how exactly is Nmap going to deduce whether a port is open or not, whether a host is open or a host is online or not? And the way it does this, right, is you send a packet, right, with either the fin, urge, push or null packet sent, or when performing a null scan where it doesn't send any TCP header flag set at all. And then based on the response, Nmap is able to tell if a port is open or closed, or if a host is online or offline. And again, when you might be saying, well, what is the response we get when a port is open? So when a port is open, you'll not get any response from the target. So it's similar to a UDP scan, right? When the port is closed, you'll get an RST, because again the port is not going to be able to respond. And similar to your three-way handshake, if a port is closed, it's going to be an RST immediately, and that terminates the connection. So again, it's very simple to understand, and I'll be demonstrating this using Wireshark. All right, so before we get started, I want to explain a few things that that will answer a few questions that you might have in your head, right? So again, why would we want to use inverse TCP flag scanning? Well, number one, many of the firewalls and stateful firewalls and packet filtering software are already set up to detect the typical SYN request being sent to a particular port from the outside, or from an external network, or from a computer across the world, right? So they usually block these or drop these, right? And another way of trying to probe as to whether a port is open or closed is to use inverse TCP flags, because the firewall or the intrusion detection system is not expecting the use of inverse TCP flags. So that's one importance of using inverse TCP flagging, is that it allows you to evade security mechanisms. And again, when we talk about the TCP flags that we'll be using, we're going to be using the fin. We're going to be using the fin flag. We'll also be using the urge flag and the push flag. And then when we talk about the null scan is essentially a packet with no TCP headers, TCP header flag set at all, right? So as I said, all closed ports on the target will respond with an RST. If there's no response, it means that the port is open. Now, another important thing to take into consideration here is that you need super user privileges to perform this scan, and the important thing, the second important thing is the operating system nuances when talking about this scan, is that this scan is these types of scans are very useful against Linux or BSD operating system, as opposed to Windows operating systems. And we'll actually demonstrate that they really don't work well with Windows. And that's because Windows TCP IP stack, or the stack onto which it's built upon, does not actually respond to those types of packets with inverse TCP flags set. So when we talk about the scans, we'll be running a few scans. We'll be running the Xmas scan, which I'll show you in a while. The Xmas scan is essentially a combination of the fin, urge and push flags all set. And when we talk about the fin scan, again, that just involves sending the fin, sending a packet with the fin TCP header set, and then Xmas again all three. And null scan does not include any TCP headers. So let's get started. Again, you can check up on these scans by accessing the man pages within the Nmap manual here. and we can find them under the service, under the scan techniques. So there we are, we have it right over here. We have the TCP null scan, the fin scan, and the XMS scan. So we'll start with them, alphabetically. So let's start off with the null scan, right? So the null scan, again, does not send any TCP header flag set in the packets, right? So if we say nmap sn, right, and we can run this against a let's see, 192.168.1.121. As I said, these scans do not work well on Windows. They are practically ineffective against Windows, the Windows operating system. So if we run this scan, I'm just going to open up Wireshark here, and we'll open up Wireshark and we'll run this scan. And the reason I'm running Wireshark is I just want to explain what's happening. So from the state over here, again, because this is not a typical three-way handshake that we're establishing, we're going to get the state of open and filtered. And that's because Nmap cannot come to a concrete it cannot make it cannot make up the decision, because again, it's inconsistent. The results can be wildly inconsistent. So again, for the most part, they're open because we did not get a response, and we can actually view this through Wireshark here. So we're just going to scroll all the way to the top. So you can see with the null scan, if you just highlight there, we have no TCP header flag set. If we click on the TCP section here, if we look for the flags, we can see they're set to none, right? If we get an RST, it means that port is closed. So in this case, port 554 is closed, port 143 is closed, port 256 is closed, 135 is closed. Port 110 is closed, etc., etc. You can keep on going. So again, this is quite effective when you're trying to avoid detection. And so yeah, that is a simple null scan. Now, when talking about the other scans, like the fin scan, which is next, let me just check that one more time. I want to go through it alphabetically. So we take a look at the scan options. So there it's a fin scan. Yeah, so the fin scan, again, is quite simple to understand. We're essentially sending a packet with the fin TCP header flag set. And again, the process is essentially the same. If we get an RST back, that port is closed. If we don't get a response, it means that port is open. So again, SF, this time 192.168.1.121. And I'll just begin the capture again here with Wireshark, and we'll hit enter, right? And we'll just wait for that to complete. And there we are, we get the same open filtered state for the ports. And if we just stop the capture now and go all the way to the top right over here, and we can see we send all the TCP packets with the fin header flag set right over here, and you can actually confirm that. And then we get multiple RSTs for the ports that are closed. So we have port 256 closed, 443 closed, and again, the ones we do not get a response from regarding so like, for example, port 80, we don't get a response back. That means that port is open. So again, it's fairly simple to understand how inverse TCP header flag scanning works. We're essentially just using all the other TCP header flags that are not part of the three-way handshake, and to actually perform these scans. And again, Nmap is able to come to these conclusions based on the results we get. So again, this is a great place to actually run the reason option here, just so that it's clear. So there we are. As I said, the reason that Nmap was able to come to a conclusion as to whether this port here was open is that it did not get any response, right? So that makes sense. So if I run this on a particular port, let's say, let's look for a service that does not exist here. If I say port 8080, for example, let's see, that might be open, but I'm not entirely sure. Let me just hit enter. So you can see in this case that port 8080 is closed, and the reason it's closed is because we got an RST from the target, and that again is conclusive towards the fact that this port is closed. So that's how to perform a fin scan. Now, when we talk about an XMS scan, combines the fin TCP header, the urge TCP header, and the push TCP header, right, all in one, and that gives you a very, very comprehensive scan. So again, the same thing goes with the XMS scan. You're essentially just sending a packet with fin, urge, and push set. And if we don't get a response, the port is open. If we get an RST, the port is closed. And it's very important to note that this will not work on Windows. And I'll actually try this out right now. But let's talk about the advantages of an XMA scan because it's used quite a bit. Number one, it's great for evading intrusion detection systems and firewalls because you're avoiding the TCP three-way handshake entirely. And again, the disadvantage is quite clear. It only works on Windows, right? So that's quite clear already. So again, this can be accessed by opening up Nmap, and I'll just scroll this through this quickly, and we have it under the SX option here, right? So we can do that right now. So I'm going to say Nmap, and we'll also run it against Windows here. 192.168.1. We'll say 121 first, right? And I'll start the capture again on Wireshark, just so I can capture the TCP header flags that are being sent here. And there we are. So I'll stop the capture, and we go all the way to the top, and there you are. So you can see it for yourself. We are sending the fin, push, and urge TCP header flags, and you can also confirm that by taking a look at the TCP section right over here, and it displays exactly what I said earlier. So again, it's sending fin, push, and urge to the target, and then for the ports that are closed, we get the RSTs back here, and for the ports that we do not get a response from, those ports are pretty much open. So again, we can also run the reason option here just to prove that again. So if a port is open, that means we don't get a response from the target or from that particular port. All right, and again, it gives you the reason summary here: 977 resets. Right, which means if there are 977 resets, that means that those ports are all those ports are all closed. So if we try this on let's see, on the Windows box, which is Metasploitable 3, and I run this, you'll see exactly what I'm talking about. So there we are. You can see it tells us that the host is up, but all 1000 scan ports on the IP for the Windows virtual machine are all closed, which is not true, because if I run a fast scan 168.1.38 on this, you can see that indeed we have the ports currently open. And remember, there isn't a firewall yet. We haven't talked about evading Windows firewall and bypassing Windows firewalls when performing scans yet. So you can see that it's essentially ineffective against Windows operating systems. So that's all that I wanted to cover in this video, and I'll be seeing you in the next video. Hello everyone, welcome to this video. In this video, we're going to be taking a look at WebMap. WebMap is a web dashboard for Nmap XML reports. Now, in addition to that, it also allows you to perform your own scans, and one of the most important features is the ability to generate really concise and beautiful PDF reports that you can use in your penetration tests. Now, as I said, the great thing about WebMap is the ability to view all your previous scans that have been stored in XML format, and the ability to run your own new scans, and with the additional functionality of being able to schedule scans, etc., etc. So this is a system or a dashboard that I really just need to demonstrate or show you so that you can get the full picture of, right? So the GitHub repository will be added as a resource to this video, and you can also get the Docker Hub link. Again, it'll also be added as a resource to this video. So I'm just going to take you through how to set this up. We're going to be setting this up through Docker. Now, if you're not familiar with Docker, we're going to leave a video in the description section or the resources section of this video to explain exactly what Docker is and how to use it. But very simply, Docker is a containerization platform that allows you to, again, run web apps in containerized formats. And again, because of that, we're able to get the Docker image here, or the actual image that allows us to create as many containers as we want. So an image is sort of like an ISO, and then your container is like a very simple VM. And the great thing about Docker is that you can run web applications or deploy them immediately with one click. So the first thing you want to do, I'm running this on a VPS. You can see I'm currently logged into it via SSH. The first thing you want to do is make sure you have Docker installed, and we can do that by typing in apt install docker.io, right? And that's going to install Docker. I already have it installed, so it's not going to overwrite it. If there was an update, it would have updated it. The second thing we need to do is we need to enable the Docker service. So I'm going to say system control enable Docker, and that's going to ensure that the Docker service will run on startup, and then I can then start the service here. So start Docker, And I can then list out information like the images that I have and the various processes that I have, or the running containers that I have. So if I use Docker PSA, that will list all the various containers that I have running. And in this case, you can see I have 0. So once you do that, you really don't need to understand what's going on. Although, as I said, we have a video covering that. You want to go right down on the GitHub repository to usage, and you want to copy this link or this piece of code right over here in your terminal. And what this is going to do is it's going to run Docker, and it's going to pull the web map image from the Docker hub, and it's going to expose it on port 8000, and it's going to store all your XML reports in the temp web map directory. And again, you can then save your reports within that directory so that they can be loaded up and used by webmap. So we'll just copy this command, and you want to go into your terminal and paste that in there and hit enter. Now I already have the Docker, the webmap image. In your case, it will take a few seconds to a minute to download. So if I say Docker images and hit enter, you can see I have the webmap image. But that the previous command that we run, or the first command that we run, or this set of commands, we'll start up the Docker container for us. And if I type in Docker PSA, you can see it starts up the Docker container for us. And if we check under the status, it tells us it's up for 19 seconds, and then it gives us the ports that it's exposed on. Now, as I said, I'm currently running this on a virtual private server. So I'm just going to install NetTools here. And I'm just going to check my IP address. This is a public IP address, and I'll say ifconfig like so, and that's going to give me my public IP, which is right over here. And now I can access the webmap dashboard by going into my browser, pasting in the IP. If you're running this on your local computer, you can simply type in localhost or use the loopback address. In my case, it's my public IP, and then I specify the port of 8000 and I hit enter. That is going to start up webmap, and immediately it'll tell you that you need a token to access this. So to generate a new token, you want to run this command within your terminal. So we'll do that right now. I'll just paste that command in and hit enter, and it's going to generate a token for us. So we will copy that token, and we will go into webmap and paste that in there and hit login, and that is going to allow us to log in, and voila, this is webmap. So I'm just going to take you through the interface a little bit, and then I'll cover the essential pieces of functionality. And this is something that you really need to experience on your own, right? So on your dashboard, it currently lists how many XML files you have, how many open ports you have, closed ports, etc. And then right down here, it lists in a table all the XML files that you have, which are essentially your scan results. If you go onto your left, you have your sidebar here. This will show you all Nmap scans. You can then take a look at all the Nmap details. You can then execute your own Nmap scan right over here. So it's very simple. You can view all your previous Nmap scans, and you can start your own Nmap scan. So first of all, let us go into the temp directory, and we go into XML, right? Sorry, we want to go into temp, and we want to go into webmap, not XML. And this is where we would store all our Nmap scans that are in XML format. So let's say I ran a simple Nmap scan here, and this is going to be an aggressive scan. We'll actually run a synth scan. We'll say this is an aggressive scan, and I'm going to run it on ports 21 to port 443. And we're going to run this on nmap.scanme.org, right? And we're going to output this in XML format, which is very important. And we'll output it as nmap.scanme.org. And I'll hit enter. And it's going to tell us, well, nmap is not installed. So I'll just hit apt install nmap. And that's going to install it. And there we are. This is again because I'm running this on a Ubuntu host. So this is a VPS that I have, and we'll just hit enter now, and that is going to start the scan for us. And again, it's going to output the results in an XML file, and we should be able to see it within the webmap dashboard in a few seconds here. So we'll just wait for the scan to complete. All right, so the scan is completed, and if we list the files here, you can see that we have the file, but again, I can just change the name here to nmap.scanme.xml because it does not have the extension. So there we have just renamed it to have the extension XML here. And if we go back to our dashboard and we show all the Nmap scans, you can see that we have one XML file that is loaded, and it essentially just gives us a summary of that particular scan. So it tells us on this particular target we have 2 open ports, and it lists out the file here for us, when the scan was initiated, the amount of hosts, etc. And then when we click on the scan right over here, it now gives us an in-depth overview of all the results that we got, and it sorts it out with graphs and pie charts, of course. And then so again, if we take a look at the top, so we start off with the scan information. It gives us the scan time, the type of scan, whether it was a TCP connect scan, a SYN scan, etc. The protocol, very important. It also lists out the Nmap command that we ran, which is fantastic. It then gives us the port status, so it sorts it out based on open, filtered, and closed ports. And then it sorts it out in terms of the ports and services. So again, in relation to one another, you have port 22, port 80. You have the ability to generate a PDF report from your results, and whether or not you performed service version enumeration and operating system enumeration. You can then check for CVEs and exploits, which we'll get to in a second. And again, you have the network view. So again, at the bottom here, you have the summary of the amount of hosts that were up if you scanned an entire network or a subnet. You then have the open ports, closed ports, etc. At the bottom, you have the services and their ports. And again, this is sorted in relation to one another. And then at the bottom, again, you get the IP address or the host or the host name of your target. And again, it lists out the services. So when you talk about PDF reports, this is one of the great features of it. So if I click on PDF report, it's going to say generating PDF report. And we want to give this a few seconds to generate. So again, we'll just wait for this to complete. And the great thing about these PDF reports is they're extremely concise and accurate. And as you'll see, they can be used in penetration tests or when writing your penetration testing reports. So you can see it gives you a port scan report, and it gives you the host name or the name of the file rather. And in this case, it gives us the arguments that were provided, when the scan was initiated, the type of scan, and the Nmap version that was used. And then it gives us a summary of all the ports and services. So the amount of hosts up, the ports and services running, the operating systems detected. And then we go right at the bottom, we have the ports that are running, the port state, the product, of course, and the version. So the service version right over here. So in this case, you can see we have OpenSSH 6.6.1 P1. And then for the web server, or running on port 80, we have Apache HTTPD 2.4.7. At the bottom here, we have the default Nmap scripts that were executed, and that is because we actually ran an aggressive scan. So that involves running the scripts in the default category. And at the bottom, we just get a summary and sort of a watermark here, which is perfectly fine. So again, you can see that the scan results and the PDF report are, is extremely concise, and it's really displayed very well. And it's displayed in a way that, the top level management or the upper echelons of an organization can understand. It's visualized very clearly. So if we go back here, we can also, as I said, check for CVEs and exploits if any of these services is vulnerable to a particular exploit. In this case, we'll just reload it one more time. You can see that none of these services is actually vulnerable to a particular CVE. And then, of course, we have the network view, right? So the network view essentially gives you this very nice, beautiful visualization of, again, the various hosts that are discovered, etc. And again, this will become more apparent when we scan a subnet as opposed to something like a single target. But again, that's something for you to explore. Now let's talk about the second piece of functionality, which is running your own scan. So if we go back to the dashboard here, or we go to all the Nmap scans here, and we click on a new Nmap scan, we can also execute our scans from here. And the great thing is that we can specify the XML file name, the parameters, the target IP or the host name, whether we want to schedule the scan, and the frequency of the scan. So for the file name, we will just say we can run this against a site like, we'll just run it again, nmap.scanme.org. So we'll say nmap.scanme, and we'll say comprehensive, right? So that is going to be the name here, and we'll just say this is XML, and the target IP is going to be nmap.scanme.org. And then we specify the Nmap parameters or the scan option. So this is going to be a SYN scan. It's going to be service version. I want to run service version detection here. And we can then run a script like something like script http enum, just a very, very simple script here. And we can then run this on ports maybe 21, or we can just run it on port 80, right? Port 80 and port 443 if it exists, and we can then say nmap.scanme.org, right? And we can then schedule it, and we can then schedule it daily, weekly, monthly, etc. However, if I disable the schedule, then we really don't need to specify those options. And I just hit start on my scan, and it's going to say your new Nmap scan is running. And once the scan is complete, it's going to tell us that the scan is complete, and it should be displayed on our dashboard with its appropriate file name and when it was and when the scan was actually executed to begin with. So it gives us the file name, the timestamp, the amount of hosts if there are more than one, and the ports that are open, etc. You get the idea. So again, we can just reload this, and based on the type of scan you run, it will take a few seconds. There we are. It tells us the Nmap scan is done. Reload this page, which we'll do. And that should display the option here. However, I'll just reload it one more time. And there we are. We can see we have the nmap.scanme.comprehensive XML. And in this case, we get 2 hosts. And if we just open this up, you can see, again, we only have 2 ports open. And if we just go right over here at the bottom, because we run a particular, again, we can see that 2 ports are open, 2 ports are closed, and the reason it's displaying this contradictory information is because we ran the HTTP enum script, and I should have just run this on port 80. But again, it's very, very simple to run your own types of scans. If you're running this locally, you can run or execute scans directly. However, given the fact that I'm running this on a virtual private server, I can't scan any VM on my network, or I can't scan my own local network. So that is all that I wanted to cover in regards to WebMap. It is a fantastic tool that allows you to, again, visualize your scans very clearly. And again, it's extremely great in generating, really a concise, accurate, and very useful PDF reports. So you can check this out. Again, all the links will be added as a resource to this particular video. And that's going to be it for this video. And I'll be seeing you in the next video.